Hi, I am Mrs. Sloan, and this is a video for my honors biology students. And this is video 2 of the nervous system. And in this video, we are going to focus on the structures and functions of the central nervous system, the peripheral nervous system, and then we will discuss some disorders. All right, I need a pointer. Hang on here. Where did my pointer go? Oh, hang on. Sorry. Turn on laser. Okay, there we go. All right, and if you are new to my videos, then down in the descriptor of this video, I have notes that my students use. They are 2-column notes. Column 1 is the scaffolding. I'll help you fill that in. And column 2, I encourage my students to put in pictures and images that help them learn this information. So for us, in video 1, we already talked about nervous tissue, the structures of the neurons, the types of neurons. We have talked about the action potential when a neuron fires and the resting potential that you need so a neuron can fire and the resetting of that. So now we're moving on to the structures and functions of the central nervous system. So the first thing I want to talk about is you have your brain and your spinal cord. That's your central nervous system. Then all the neurons outside of that, that is your peripheral nervous system. And when you look up here, and this is a great chart to kind of help keep things straight. So brain and spinal cord are your central nervous system. So you have nerves that are coming off your cranium and coming off your spine. So you have 12 pairs of cranial nerves and 31 pairs of spinal nerves. Now, those nerves are going to be made out of sensory neurons going towards your central nervous system, or motor neurons going away. And then as far as the motor neurons going away, you have your somatic nervous system, which is everything for your skeletal muscles, mostly choice except for reflexes. And then your autonomic nervous system takes care of your heart and your organs, your smooth muscles. And we'll talk about the divisions of that as well. So on your central nervous system, brain and spinal cord. So the first thing we want to talk about is on the introduction, 17.2, sensory information is received and motor control is initiated through your central nervous system. The meninges are the protective membranes. There are 3, the pia, the arachnoid, and the dura. So I remember that because it pads, P-A-D, pad, starting with the innermost. And the arachnoid kind of looks like a spider web. And then the dura is very durable. It's on the outside. So the meninges are a protective membrane around your central nervous system. There's fluid amongst that. There's fluid down through your spinal cord, right here in your central canal and around all the tissue. And that cerebral spinal fluid fills in the spaces, cushions, and protects. That's what you need to put in your notes, protects your central nervous system. Okay, let's take a look at this. Oh, the door just slammed. Let's take a look at the spinal cord. This would be somebody like face down and you chopped them just like this and you're looking down through their spinal cord. Can you see how it looks a little bit like a butterfly right here? Now I want to get out of the way and remind you about the structures of a neuron because it'll help with this. So remember a neuron, and the picture got cut off. Sorry here. There's the neuron right here and the cell body. What I wanted to show you is off here to the left where the nucleus is. And then here, this is the myelin sheath that runs along the axon. So when you look at, you can see this gray matter here and then the white matter. The gray matter is holding all the motor neurons going away from your central nervous system, their cell bodies. And this white matter is white because of these myelin sheaths. So he's going in and out of my house and the door's slamming. These myelin sheath right here are going around the axon. So on your notes, spinal cord structure, gray matter has cell bodies of motor neurons and interneurons. Remember, interneurons connect your sensory neurons to your motor neurons, and interneurons, it looks like a butterfly. And then the white matter are all the myelinated axons. And then the central canal are myelinated neurons, that's fine in the notes. And then the central canal is filled also with cerebral spinal fluid. Now, if you had an infection of the membranes around it, we're going to talk about meningitis. We'll talk about all of that towards the end. All right. Now, looking at the spinal cord, this is somebody facing you, okay? And you can see that butterfly again. What I want you to see is you have these 31 pairs of nerves coming off your spinal cord. There's a split, right? And going in the back, towards the back of you dorsally, this is where the sensory neurons enter, okay? And coming out ventrally towards the front, like the front of the butterfly here, those are your motor neurons. But then they're joined like a two-way street, right? Right outside of it but sensory neurons go in the back of your spinal cord and motor neurons are coming out the front. And here too, you can see the meninges right here, the protective membrane that we have around the brain. We have those membranes again around our spinal cord. Okay. And the function of your spinal cord is all about reflexes. So reflex actions. And then it's going to send sensory information. Remember, coming in dorsally. This person's face down now. Sensory neurons are coming in dorsally. And do you see this dorsal root ganglion right here? This is where the cell bodies are of the sensory neurons right here. Okay, and then you can synapse here with an inner neuron, and then motor neurons are coming out the front. So it sends sensory information to the brain, and it receives motor. This is what your spinal cord is doing. It's receiving motor information from the brain, motor output, and then the tracks cross over. The left side of the brain controls the right side and vice versa. All right, and we'll talk more about reflexes in just a little bit. Okay, now let's focus on the brain itself. Okay, so all these folded parts right here, you're going to think cerebrum. What do folds do? They increase surface area, right? More processing. So just looking front to back here on your brain, your frontal lobe, look at these executive functions, thinking, planning, organizing, problem solving. Then right here is your motor movement out. Okay, sensory information, sensations coming in here. Parietal lobe, what are you doing with those senses? Your perception, making sense of the world. Your occipital lobe is all about vision. So some people can have vision issues, not because they hurt their eyes, but where they process that information in their occipital lobe. And then your temporal lobe right here, about memory and understanding and language. So I'm going to group them all together for you. You're not going to have to memorize these different regions, so don't stress out about that. The cerebrum, what I want you to have is it receives sensory information, it integrates and sends a motor response. So it receives sensory information, it integrates it, processes, and then sends a motor response. It will communicate and coordinate your entire body. And in fact, here you can see how much of your cerebral cortex is dedicated to different parts of your body. So let's look over here at the right first. So this is your somatosensory area. So based on how large the structure is, you can tell how much of your brain is processing that sensory information. So look at all the sensory information surrounding your face and your hands and your tongue, right? Breathing. Okay, and then this is showing you what's dedicated to motor movements of your cerebral cortex. Remember the front right here of this line would be the motor, and then right behind it is the sensory information. So on your communicates and coordinates the entire brain. It deals with sensation, reasoning, learning, memory, language, speech. Right? And then here is another picture. We'll kind of break it down in cross section. So you can see all the folded area here, the cerebrum, the meninges, the 3 layers are right outside of that. Next thing I want to point out to you, you can see the spinal cord coming up here. And then I want to just pre-show you a few things. Here's your medulla oblongata. Do you remember when we talked about that earlier with the circulatory system and controlling how fast your heart is beating? And then your pons is up here, this kind of swelling. It looks like, I always think ping pong ball. I know it's lame, but the pons is that. Then you have your midbrain right here, your cerebellum. Think Sarah the ballerina. It has to do with balance. And then you have your thalamus and your hypothalamus. Your thalamus is what looks like a fried egg right here. And then your hypothalamus sits right below it. And below that is your pituitary gland, which is called the master gland. All right, so kind of an overview of all those things. Let's focus now here on the diencephalon, the thalamus and hypothalamus. I think I gave you everything for the cerebrum. So for hypothalamus, you want to think homeostasis. It is 100% nervous tissue that is in alignment with your pituitary gland. And your pituitary gland is the hormones, and between your nervous system and your endocrine system is how you are the chief systems in charge of controlling and regulating your body. So for hypothalamus, put homeostasis. And then you have on there regulates hunger, sleep, thirst, temperature. And the hypothalamus is the link. That's the other word you need. The link between the nervous system and the endocrine system by controlling the pituitary. The pituitary, that's Pituitary. T-A-R-Y, the pituitary, which is the master gland. It's not labeled, but this is your pituitary gland right here. And there's a posterior and anterior pituitary. There's like 2 sections to it. All right, then your thalamus, the thing that kind of looks like a fried egg right here, your thalamus integrates the sensory information. You have that, sends it to the cerebrum, also participates in memory and emotions. When you have smells that remind you of an event or something, or, you know, those type of connections of memories and smells, that is all your thalamus, right? And you have all the notes for that. All right, your cerebellum, I always think of Sarah the ballerina. This helps you with your balance. So cerebellum integrates and passes on both sensory and motor information, gets processed through that. It maintains normal muscle tone, posture, balance, and coordinated movement. If we were in class right now, I would tell you, like, if I would mimic walking. When you walk, you know, your cerebrum would just tell you these rough steps, but your cerebellum kind of smooths out the motions of your walking. Okay, so it kind of fine tunes it. When you will never let this happen to you, but if you got pulled over for drunk driving, one of the parts of your central nervous system that is affected is your cerebellum. And that's why they would have you close your eyes and touch your nose or stand on one foot, because that would be a good indicator that you were intoxicated. All right. Here you can see your brainstem. It's this whole region in here. So breathing, heartbeat, articulate speech in particular. Okay. So we have our midbrain and we have our hindbrain, which are these things. Don't get caught up in that. That's all right. Pons, your medulla oblongata is right here. And then this transitions into your spinal cord. So on your notes, we are at brainstem. The medulla oblongata regulates breathing, heartbeat, blood pressure, vomiting, sneezing. These are like things to stay alive. Breathing, heartbeat, right? These are to keep you alive. And it's great because it's buried so deep, right? And protected, where everything out here is pretty much quality of life. This is staying alive and this is quality of life, right? Okay, so breathing, heartbeat, blood pressure, vomiting, sneezing, your pons and your midbrain. Pons is this right here, works with the medulla oblongata and controls your cerebellum and the rest of the central nervous system, kind of connects everything together. All right. Now, your limbic system. Your limbic system is several areas of your central nervous system, several areas here of your brain. So what I want you to have is it's deep in the cerebrum and the surrounding diencephalon. Remember what the diencephalon is? Let me go back here. So your cerebrum and your, your diencephalon, which is your hypothalamus right here, and your thalamus, okay? And it is involved in both memory, learning, and fear, anger, and pleasure. This is like your lizard reptilian brain is your limbic system, okay? So memory, learning, fear, anger, pleasure. And your limbic system is involved in drug abuse. All right, so now let's transition. We're done with the central nervous system, which is the brain and the spinal cord. And now we're moving on to the peripheral nervous system, everything outside of the brain and the spinal cord, all of these nerves. So on your introduction, outside the central nervous system, but attached to it. So remember what a nerve is a bundle of axons, So there's a lot of neurons in one nerve. On breaking down your peripheral nervous system, we have 12 pairs of nerves coming off of your cerebrum. So I want you to look right here, number 5, see how it comes from the mouth, that would be sensory, and to the jaw muscles. That means that that particular nerve has both sensory and motor fibers in it, right? This one, number 3, says 2 eye muscles, so what would that be? If it's going to the eye muscles to move your eyes, then that would just be a motor neuron, right? From the retina of your eye, that would be just full of sensory neurons, all right? So some of these are dedicated sensory nerves, some are dedicated motor, and some are mixed nerves, having both sensory and motor fibers. Now, off your Your spinal nerves, you have 31 pairs of those. They are all mixed. They contain sensory and motor, every single one of those. And remember what I said, sensory neurons are coming in the back. This person's laying face down, okay, face down. And sensory neurons are coming in the back. This dorsal root ganglion is holding the cell bodies of the sensory neurons, and then motor neurons are coming out the front. All right, so on your, let me show you right here, okay, on your nervous system, so you have central, brain and spinal cord, peripheral, everything outside. Of that, you can break it down to somatic and autonomic. Somatic is anything to do with your skeletal muscles, which are usually a choice, except if you have a reflex, like you're trying to duck away, where you're not even processing it, right? In a reflex, when you touch a hot pan, you're not waiting to go, gee, that's hot, and then pull away. As soon as you touch, you pull away. And that's because those sensory fibers going in are synapsing with the motor neuron right away when you have that overstimulus of that heat. So you'll pull away. That would be very protective. You also have neurons going up to your brain, because oftentimes when you pull away from a hot pan, then you go hot, right? You've already pulled away before you have this idea of it being hot in your head, okay? So that's all your somatic nervous system. Autonomic nervous system, put a pin in that. We're going to come back to that. So for your somatic nervous system in the reflex arc, the target is your skeletal muscles. Target is your skeletal muscles. It consists of sensory neurons going towards your central nervous system, and then it synapses with an inner neuron here, and then a motor neuron going away. Now, I don't know why, if your skin touched a tack, I don't think you'd go like this and jam that tack into your skin, but this is what they have you doing here. So sensory in, synapsing with an inner neuron, motor neuron, and then pulling away in your reflex arc. Also neurons going straight up to your brain as well. So reflex pathway, you have a stimulus, in this case a pin, stimulus, sensory receptors enter the dorsal root of the spinal cord. You can see that coming in the back. Sensory receptors enter the dorsal root, then interneurons of the spinal cord. And then you have motor neurons exit the ventral roots of the spinal cord, the front, and then the skeletal muscles will contract. Skeletal muscles will contract. All right, now let's talk about the autonomic. I think automatic when I think autonomic, and you have two, sympathetic and parasympathetic. Sympathetic is stress, whereas parasympathetic is relaxation. So I always think I feel sympathy for somebody who's under stress. So this is fight or flight, and this is rest and digest. Okay, in a nutshell, fight or flight, sympathetic, and rest and digest in parasympathetic. So on your autonomic system, the introduction, it's involuntary control of smooth muscles of the internal organs, glands, and cardiac muscle. The sympathetic division is your stress response. Okay, and so here, remember you have 31 pairs, right? Most of your sympathetic nerves come out right in the middle of your spinal cord, are your sympathetic nerves. And you can see things like it accelerates your heartbeat and dilates your lungs. It inhibits digestion, converts glycogen to glucose, secretes adrenaline. This is all your sympathetic. So it's stress response. Parasympathetic comes out here at the top of the spinal cord and the bottom of the spinal cord. If you look what it does, it slows the heartbeat, stimulates peristalsis and secretion of digestion, so you secrete bile, which you need for fat emulsification. So parasympathetic is the relaxation response. Relaxation response. All right, drugs, don't do them. Okay, unless you have to take an Advil or something. So drugs, ultimately what they do is you put a chemical in your body that affects the actions. It either promotes or prevents the actions of a neurotransmitter. Okay, so on your notes, drugs promote or prevent the actions of a neurotransmitter, and it impacts that reptilian brain. It impacts your limbic system. So that's why it helps some people. They'll become very anxious. Some people will become anxiety ridden because it's part of that kind of basic brain response. So how does it do that? So you could have a leaky neurotransmitter, what you have here. You could prevent the release of a neurotransmitter. You could promote the release of neurotransmitter, prevent the reuptake of a neurotransmitter at a synapse. You could block an enzyme that would normally break down a neurotransmitter, or it could mimic a neurotransmitter. So that's in essence what drugs do. So you have impact the limbic system, and then addiction is you more and more of the drug is needed to get the same effect, right? Somebody, let's say, who uses alcohol, which is a depressant, they might get drunk from one beer, but if they're drinking several beers every day to get that same sense of drunkenness, they need to have 3 or 4 beers, okay? And they need it, and if they don't have it, then they go through withdrawal symptoms. I have never met a drug addict who was glad they were a drug addict. And I have never met somebody who it's not like you would willingly go into that for most part, right? And so what I'm telling you is, if you're using drugs to comfort you or to ignore something or make you feel like you could do something you couldn't normally do, not a good sign. It does lead to addiction. You can only look at the millions and millions of dollars that have been put out there trying to help people quit things like cigarettes, right? Quit alcohol. And the impact on every family has somebody who's probably had an addiction, and how that impacts the family dynamics. There's a lot of broken hearts surrounding addiction. So I'm going to tell you, if this is something you're struggling with, if you're one of my students, please come talk to me. You can go to a counselor, talk to somebody at your school, talk to your parents if you can, a trusted person, and let's get this taken care of. The earlier, the better. All right. There are lots of helplines that you can call for addiction, and start that process of healing and getting away from that drug. All right. I don't mean to belittle it, but I do want to address it. All right. So now let's talk about some disorders of the nervous system. The first one, and this may affect some of you, is if you know somebody who has Alzheimer's, like a grandma or a grandpa or an uncle. So Alzheimer's disease is associated with dementia. Their personalities change. They don't respond the same way. They forget things. It starts off with just being a little bit forgetful, and then usually they kind of try to wing it, and they're embarrassed that they've forgotten something, and then it gets worse and worse. And when they respond poorly to you, it's not you, right? They become a different person because of the dementia. Okay, so Alzheimer's disease, dementia. Parkinson's disease. Parkinson's disease is often associated with tremors. Normally, you need dopamine from normal neuron function, and they are not making that anymore. So those messages are not good, and you see those tremors. Parkinson's disease is a gradual loss of motor control. Gradual loss of motor control. Multiple sclerosis. Multiple sclerosis is an autoimmune disease. This is when your immune system attacks your own tissues. Specifically, the myelin sheath is attacked, that protective coating. So autoimmune disease where the myelin sheath is attacked in the neurons of the brain, causing fatigue, problems with vision, weakness, pain, etc. All right. Stroke. We've talked about strokes before that's my dog barking. We've talked about strokes when we talked about the circulatory system. So it's a part of the brain is dying. What are signs of a stroke? It's called Be Fast to help you remember. So somebody who's having a stroke could have issues with balance, headache, dizziness. If this is also accompanied with blurred vision, you need to call right away. Okay. One side of the face could start to droop, arm or leg weakness, speech difficulty, and the coordination of that. Then it's time to call an ambulance immediately. The sooner that they can address that, the better on a stroke. So you want to be fast about it. So a stroke is a loss of blood to brain tissue and then loss of function in that area. All right. Meningitis. Meningitis is an infection of the meninges. Remember the pia, the arachnoid, and the dura. You could have a bacterial infection in there. Symptoms of meningitis are things like headache, altered mental status, could be a high fever, seizures, stiff neck. I remember because I knew about meningitis, one of the things, if a child is having it, the sooner you can get it to them, the better. And one way is to have a child lay on their back. By the way, I'm not a doctor, so don't use me as a doctor, but to kind of curl, if you're laying on your back, to curl up in a ball like this, to help them curl up in a ball. They would cry out because that increased pressure from the inflammation. And that was a sign of meningitis to get them right away to the hospital. So it's an infection of the meninges. All right. And then a common issue is having just a bad back, right? Pain in your lower back. And that has to do with the whole upright, being the cost of being upright. But if there is damage to your spinal cord, depending on the location and the extent of the damage, what you have as far as loss of function, the higher it is, the closer to your brain, the more loss of function that you have in your body. All right, so depending on the location and the extent of the damage. And then ALS, Lou Gehrig's disease, it affects motor nerve fibers, and usually on the onset of ALS, you have about 5 years to live after that. So I know that's stressful to hear about all these things, but if we know maybe about the symptoms of them, and then we can diagnose them early and get people help, right? That would be the way I would phrase it. And you know what? If you're one of my students, I'll see you in class.